5, 4, 3, 2, 1. We have ignition and liftoff.
Millions of pounds of investment at stake. Decades to design and build. The eyes of the world watching. With so much at stake when trying to land a probe on another planet, it's always wise to practice first. Across the country, there are many practicing scientists and engineers keen to work with schools and help lift the curriculum out of the textbook and bring it to life. A visit from one of these STEM career role models is a great way to engage students and show them just how far the skills they learn in science, technology, engineering and maths could one day take them. As Cowplane School discovered when they had just such a visit from spacecraft engineer Faye Cashman.
My name is Faye Cashman. I'm a systems engineer here at Astrium in Portsmouth. What that basically means is I get to work on different kinds of spacecraft systems. This can be anything from communication satellites to building satellites to go to other planets. Also, we work on things like a Mars rover to go onto Mars, generally anything to do with space. Well, I joined Astrium in September 2007, so I've been here for about a year and a half. I'm actually on their graduate programme, which means I get to rotate around all different departments around Astrium. My current project is actually called MIRI, which stands for the Mid-Infrared Instrument. This is actually one of the instruments on the James Webb Space Telescope. This is known as the replacement for Hubble. It will be out in deep space. It's meant to be launched in a few years' time. It's basically designed to look back right at the beginning of the Big Bang, at the point where we can actually see what's happening. It's actually designed to look in the infrared. That will help actually look through lots of the dust and things that currently are in planetary nebula. We can't actually see through them. Infrared allows us to look through them and we can actually see what's going on.
Today, Faye is visiting Head of Science Stacey Kemp and her Year 9s at Cowplane School near Portsmouth. Along with colleagues Martin and Scott, she's brought along an extra special member of the team. Meet Bridget.
This is Bridget. Say hello to Bridget. Hi, Bridget. Well done. And I'm sure you can guess, she's designed to roam across a planet's surface, and she's designed actually to roam across Mars. That's obviously why we've got all the orange rocks and things like that. She's a prototype model. She won't actually be going to Mars. Her top speed is 150 metres per hour. But of course, we don't really want to go zooming across Mars because we're actually there to explore it.
One obvious benefit of Faye's visit is a chance for the students to see the kind of cutting-edge technology that's not so readily available to most science teachers. Technology that she hopes will excite the students enough to make them consider a career in engineering.
You don't usually get to see £1 million spacecraft in your sports hall. It's like £1 million. It's amazing. It's actually live there.
So then, why do we want to go to Mars? What's the point? Yep.
So you can see if there's life there.
That's it, exactly. Well done.
The Mars rover will have the capability to drill down into the surface and grab bits of rock, take them inside the unit and analyse them there, and then send us back the results.
It was quite interesting seeing the Mars rover because I'd never seen a proper spaceship apart from on the telly, and it was quite interesting to know that something similar to that would be going up onto Mars.
Won't keeping Bridget on Mars because she's metal. She won't biodegrade or anything.
Part of the reason that she is metal is that it's trying to minimise the impact we have on the planet while we're there. We don't want to give false indications of signs of life. So things like having rubber wheels, which are made from sort of organic compounds, would mean that it would degrade, and you'd sort of drill up a bit of your own rubber and think you'd found a sign of life. So it being metal, yeah, you'll have your rover there that won't actually degrade, but it shouldn't damage the planet or have an effect on the atmosphere.
We're in my office at the moment. This is where the MIRI team work on the James Webb Telescope. We do a variety of things down here, from working on paper engineering through to optical modelling and having lots of teleconferences with the people that we work with across the world. Basically, a customer will place an order with us to build a satellite, say for example a communication satellite, and then what we do is we can agree the design and the actual objectives, what we want the satellite to actually do. Then this process, all the information will get sent over to the manufacturing area. Okay, we're now in one of our big clean rooms. This is where we actually build some of our components for our actual spacecraft here. We're in actually a class 100,000 clean room. What that means is, per cubic metre of air, there are 100,000 particles of like dirt and contaminants. So what we have to do is dress up in these lovely outfits you see here, basically just to protect the components that we're building. Otherwise, if contamination gets into them, they might not work properly. The circuits and things we design are very small. The smaller something is, less it weighs, less it will cost to get it up into space. We're now in actually our main satellite integration room. As you can see behind me, this is actually a satellite panel. And as you saw in previous clean rooms we were actually building smaller components. These actually get built up now onto an actual satellite panel, like this one, and this will all get integrated into an actual main satellite. Once the satellite's actually built, we put it through vibration tests and thermal cycles to simulate the launch and space environment and to check it will still work. Then it will get shipped over, depending on where we're getting launched from. We have a launch site in South America. It will get shipped over there possibly, put on top of a rocket and get sent up into space.
Building spacecraft is just the start. Getting them to another planet is the real challenge. A Mars rover has to survive the launch, the journey, and most importantly, the landing. Faye now wants to see if the students have the necessary engineering skills required for such a feat.
What did you think of her?
Their payload won't be quite as priceless, but it will be just as delicate.
So what we're going to do, we've got those materials on the front here. We're going to have a bit of time then to come up with a design, and then we're going to test your design and see if your egg will survive landing on the planet.
I know, but you can't exactly get egg inside the egg.
Hold in half, yeah. Cut it there. So if we put that at the bottom of the egg.
The main goal of our Mars Egg Lander activity is that the students are able to build something that will protect their egg. So when we drop it from a certain height, it will land safely on our planet, i.e. it won't break up. So have you guys thought about any ideas how you're going to use the material to protect your egg?
Dan wants to put the balloon inside the balloon and then put the egg inside the balloon.
Do you think you can get an egg inside a balloon?
You probably cracked the egg before we got it in the balloon.
It's a raw egg.
try.
It's a raw egg, yeah, you're right, it's worth a try. However, we sort of have to think about the fact that once your egg's gone, that's it, your precious payload is gone.
Balloons, bubble wrap, string. The materials may be different, but the engineering skills the students learn relate directly to those employed by Faye and her colleagues.
I think sometimes when we're just teaching in classes and teaching lessons, they don't necessarily associate how the science they are learning relates to the outside world and the kind of jobs that they could do when they leave school. So it really opens their eyes to the type of things that what they're learning can lead to in the future.
Looks like a nappy.
What?
That's our going to be your parachute sort of idea, and then we're going to get this thing in the jiggy, cut it in half. Sponge, cut it in half, stick the egg inside of it.
It's padding.
It's padded, close it up, then use this thingy to wrap it up.
J cloth.
Put some of this stuff around it.
Bubble wrap.
What do we have left? A bit of string and paper.
The students are clearly enjoying themselves, but is it all as much fun in real life?
I think the main thing that excites me is I get to work on something that's going to go into space one day. You know, not many people get to say that about their job. That for me is a big plus. The other sort of main thing I really enjoy is I get to meet people from lots of different industries like NASA, like ESA, which I've always wanted to do. I definitely recommend what I do to students. It's like I say, it's very exciting. It's not a case of you have to be the most brainiest person in your class. I mean, I'm certainly not. You have to work hard like I did. It was a bit tricky at school. I didn't get the best A-levels, but when I got to university, I actually found the environment there a lot easier to work in, and I soon applied myself and did well. Sticking with science and engineering is so important, especially for young people these days. As we hear all the time in the news, there's such a skills shortage in this country. And like I say, you get to work on things that go into space. I don't see why people wouldn't want to do that.
Back in the classroom, the moment of truth has arrived. It's time for the students to discover which of their eggs will get scrambled and which will land sunny side up.
I'll hold it and you can explain your design.
Okay. We've got a paper parachute to slow it down, and there's inside it's wrapped in bubble wrap, and it's got the cushion at the bottom, and it's wrapped up in this to keep it together.
We have to have a countdown before we launch. So 5, 4,
4, 3, 2, 1.
Oh.
Okay, let's have a look.
See who survived then.
Yeah.
I was really impressed by the designs and the engineering skills of some of the students today, and I feel that they really got thinking and putting the science into their designs.
We cut the sponge in half and put the egg inside, then wrap that in bubble wrap and wrap that in the J cloth.
And then we were going to put the balloons on top, but because they're not filled with helium, they wouldn't have done anything. So we put them on the side to act like a little bouncy stopper thing.
Oh, so you thought a lot about it, that's good. So do you think it'll make it then?
Probably not.
Yeah.
Optimism, that's what we like. Yeah, okay. How about the rest of you? Do you think the egg will survive?
No. I think it will.
A bit mixed opinions there. 2, 1. That was quite, I think that was quite controlled.
That's how I like my eggs.
It's good, it survived. It's good.
That's what I'm talking about.
Well done. Good engineering. Well done. I think it's a good thing that people like myself go into schools and encourage kids is because then they see someone real. They see someone, okay, not very old, but fairly young, like myself, who actually has been through what they're going through, and sometimes they can relate better to younger people. And I just think it's easier than they just read it in a textbook. I think that interaction is why it's so important to actually get people in the industry to go into schools.
Egg but the first has survived.
So well done everyone. I hope you actually enjoyed it all and you enjoyed learning about Bridget and a bit about Astrium as well. So thank you very much.
So do the students think they could do this for real?
Maybe I could land a probe on Mars one day, I don't know.
I think I would be able to land a probe safely on Mars, but you'd have to have a lot of skill.
I might be able to land a probe on Mars, but probably not. I'd land it, but it would break.
I think one of the ultimate goals of today is to get kids to think, yeah, this is a really good career choice. I'd be quite interested in doing this in my future. So hopefully, yeah, we've got a few more space scientists coming up in the future, which would be great.
It made me more interested in engineering and science because instead of just being a lesson with writing, it was more practical.
I think I might go to into a career of science engineering because it was really interesting and just different from what you usually do.
I think overall the day's been absolutely brilliant. I think the students have got a lot out of it, and if I asked them tomorrow would they do it again, then the answer would be yes, definitely.
3, 2, 1.
Was that?
It has cracked, but you protected it so well that the yolk has stayed inside.